tout le monde. I will be presenting to you a platform that we're very proud of here at Illumina. Obviously, if at any moment, I don't know, do you usually work with questions during presentation, or do you prefer question periods after the presentation? I don't mind either way. What's your usual format?
Yeah, generally it's after the presentation.
Okay, sure. Well, so we'll do questions after the presentation. That sounds good to me.
Thank you.
My job at Illumina is I'm the field bioinformatics scientist for the Canadian market. So I help customers with most of everything to do with Illumina bioinformatics. So I can go from supporting the customers, but also all the way down to integrations, implementations, custom projects when it comes to trying to enable customers that use Illumina products all the way down to data generation and analytics. So I come here today to present the Illumina Connected Analytics platform. And so this is, there's a very, it's a repetitive speech that we like to discuss when we talk bioinformatics, and that is the ever-increasing amount of data that we generate in the field of bioinformatics. And I just realized that I was going through my slides and I have not started sharing my screen yet. So let me do that. There we go. So that looks good. Structure of the presentation, I'm going to go through what is ICA, what's the general idea, and what problem we're trying to solve with the platform. We're going to discuss some of the features really quickly and use cases. But most of all, I want to show you what it looks like when you work on it, and how it may benefit you as a bioinformatician. So in order to answer the question of what is ICA, the eternal problem of bioinformatics is we're generating a lot of data that basically in all of the surveys that we've had with our customers, one of the most recurring complaints is we're generating a lot of data and we're constantly underestimating the amount of time and the amount of effort that is required to process that data to generate insights. And so just to give you some numbers, in 2019, just on Illumina sequencers alone, we've generated about 150 petabytes of data. And that number keeps increasing. I can tell you with high confidence that that number exploded after 2019, especially with the increased interest in anything to do with genomics, bioinformatics that came with COVID. And so that keeps pushing everyone that has to work with any type of omics data to rethink the challenges that are posed by the data generation itself. What to do with storage, how do you make sure that you store securely, and then obviously how do you process the data, how do you generate insights, and how do you make that an organized process as part of a production framework. And so the challenges that, the main challenges that we've identified, the first of all is very obvious, scaling up infrastructure. That's always difficult because when you scale up infrastructure, you have to try and think ahead. You're not going to do upgrades monthly. You're going to do an upgrade program that's going to last for a couple of years. So you have to already be able to proactively assess what you're going to need. Infrastructure has also the added issue of coming up with maintenance problems. You need to provision for the new infrastructure that you're going to be building up, but also for all of the maintenance that is required, all of the logistics.
Sorry, we didn't see your presentation.
Oh, is it? Can you see my screen share? Is that?
No.
Oh, let me. I can see it here, but I can also see something else. Let me restart that.
Okay, I just.
How about now? Can you see my screen? Okay, all right. So where was I? Yeah, scaling up infrastructure. First challenge we've identified. Data siloing is another one. You're working on a project. You try to collaborate with someone else in a different country, in a different institution. First question is, how do we shuttle the data back and forth? How can we do that securely? Who is the custodian of a data that was generated by a multi-organization collaboration? Maintaining security, privacy, and compliance. That's a topic that, every couple of months we hear of an institution that gets hacked, that gets, that loses data, that, mistakes happen. Building and deploying new workflows. So that's the constant challenge, but that's just part of bioinformatics. I don't think that's a challenge that can necessarily be solved, but we can definitely build tools to make it easier. And obviously, last but not least, oftentimes bioinformaticians are very solicited people. Their institutions never really have enough bioinformaticians, but they always try to maximize what they can do with the informatics staff that they have on hand. So those are the challenges that we've identified, and we've tried to build a platform to try and address as much as possible these challenges. So this is the vision. Essentially, we built a platform that has a seamless integration, obviously with our sequencers. We are Illumina, but also that can make life easier to integrate any type of data. The platform is data agnostic. It can accept any type of data within it. And then within ICA, we've built a framework in order to allow for building and running and orchestrating pipelines, data management through data warehousing, databases, etc., and modules to help for insight generation, data science, anything downstream of your data generation. So yeah, well, that's what the challenges that we're trying to address. So the main features. Essentially, we've implemented orchestrators that run CWL and Nextflow code. So these are workflow design languages. So you write the definition of your workflow within CWL and Nextflow. We've built on top of that, on top of CWL specifically, more of a GUI approach where you can drag and drop tools and sort of link them together, but you can also do that completely with code. We've built a layer on top of AWS S3 in order to allow you to manage your data in a secure fashion and to add a ton of relevant metadata for bioinformatics applications. And we've added a lot of tools. We will discuss that to help enable people that work with Jupyter Lab notebooks that want to query and store large amounts of data in databases. So so within the platform, it's very much intended to be as infrastructure as a service. The platform is there to allow you to detach yourself from the limitations of your own local infrastructure, but we've also integrated some of our own Illumina software, Illumina pipelines. If you're familiar with Dragon workflows. We've integrated those de facto within the platform, but obviously the goal is to enable bioinformaticians to sort of have a blank canvas where they can design and deploy any type of workflow and run it. The main advantage is really the hardware. You'll be able to requisition cloud compute on demand for your workflows. We've also built data warehousing capabilities on top of Snowflake. So Snowflake, for those of you that are familiar with it, think of it as the equivalent of AWS, but for cloud databasing. Again, we've built in tools to allow you to analyze and look through your data through Jupyter Notebook environments that are preset, but those are also customizable. So if you prefer a different kind of environment than Jupyter Lab, you can also set that up and have it linked up with your data on the platform. We run on top of AWS. So we've deployed our platform in 8 different global locations in the cloud. So we do have one using the Canadian deployment of AWS. So the use cases, the typical use case is very much, you want to automate the process of getting your data from a data generating source, whether it could be, a sequencer, it could be something else. Again, the platform is data agnostic, so it can read, you can, push data from any sort of omics generating aspect, or even non-omics. Frankly, you can even run non-omics data analysis on top of this, and then have a centralized location for data processing, for pipeline orchestration. And then obviously there's a lot of collaboration tools so that collaborators can then come in and do data science, generate insights based on the data that you've generated through your pipelines and workflows. So that's it for sort of the quick intro. We're going to go to a practical demo of what the platform looks like. So let me pull that up. There we go. So this is what the platform looks like. This is the GUI on the web. I'd like to also mention that everything I will do here in the GUI can also be done through APIs and CLIs. So the whole automation aspect, nobody automates through GUIs. And so the main concept the main unit that you want to think of in Illumina Connected Analytics is the project. Everything is split through the project concept. And so the project is going to be the custodian of your data. Everything is split by project. Every project has their own owner. There's also very granular level of permission. So if you want to collaborate with, just give me a moment here. There we go. So if you want to collaborate with other people within a project, you can add users. So there will be users that are listed within your domain that I can just grab a user that's already listed and add them, and then control what this user can do. I can control whether the user can upload data, download data, what can they do with the data. There's different roles with different levels of permissions. Can they run pipelines, or are they just here to look at the result of the pipelines, in which case they will be listed as a viewer. You can group users into what we call work groups. So work groups are basically groups of users that can share the same level of permissions. You can also just add a user via email, in which case they don't have to be part of your organization. You can send an explicit invitation to a user just via this email text box here, and they will have access to this project specifically. And so obviously for the data aspect, everything is stored on S3. but we do have quite a significant amount of metadata that that we've built on top of S3. So when I click on one of these data fields, for example, there's a unique identifier that is linked to each data field. They will have a path, obviously, within the project. They can have a number of technical tags that are automatically generated by the platform, but they can also be tagged by the user. Again, that helps users to be able to easily tag different types of data for an easier querying down the line. There's also automated mechanisms for archival and deletion, so that helps a lot with data management. We've really tried to pack as many features as we can to help provide tools for automation down the line for bioinformaticians, so they can just build an SOP, set it up, and sort of fire and forget. You just let it go. Data will automatically get archived at a specific date, automatically deleted at a specific date, depending on the policy that is chosen. So the way workflows are meant to be designed, well, there's two ways. There's a fully, I'd say, programmatic and coding way, but there's a more interactive way. The interactive way, and we call that the graphical method, is that we have built automatic code generation off of on top of CWL. So, for example, I can go here and grab. This is what we call tools. So tools are the singular components that form pipelines. And so this tool here, VCF compare, runs a VCF compare Java. And you can see here how it's defined. The tool base command is colored in pink, and then you have a number of arguments. The inputs are in green, and then you have a number of parameters that are in yellow. And the way it's set to, the way the tool creation design is made is to sort of simplify this as much as possible. So I can create a tool here called test. You have to predefine Docker images. So any command that you define in your tool is going to be run on top of a specific Docker image. So you can containerize every step of your pipeline. And so Docker images can be provided as an external URL to Docker Hub, for example, or if it's more of a sensitive application and you don't want your Docker image to exist externally or easily accessible, you can also package it as a tarball and provide it to the platform. So in this case, it's going to look through a bunch of Docker images. So I can grab, just any random Docker image, for example, this one here that has tab X. There's a versioning system, and then you have all these tabs where you can come here and say, I'm running Java here, and that's going to be your base command, and then you're going to go and define an input. Again, I'm just showcasing how you would easily do it. You have labels, you have descriptions, you can give your input a position, you can give it a prefix. And if you're familiar with CWL, this is going to sound very basic, but this helps a lot for bioinformaticians that are maybe not completely familiar with CWL yet. Maybe they want to keep some level of interactivity to the way they work. But in the end, what's going on in the back is that it's automatically generating the CWL code in the back for you and showing you what's actually going to happen. And once you've built a couple of these CWL tools, what you can do is go back inside. I'll say I don't need this. You can go back inside one of your projects, go under pipeline, and then I will show you a pipeline that I've built. So I've built this. I've built this Trinity pipeline that has a bunch of annotation steps. So each one of these is a tool that was built just the way I quickly showed earlier. I've defined some inputs, I've defined some outputs, and the way. So essentially, what this pipeline is doing is that it's running Trinity, which is a tool to assemble transcriptomes from RNA-seq data, and then I'm using an annotation method that is defined in a tool called Trinitate that depends on translating your transcripts into proteins by looking, predicting the ORFs, running BLASTP on that, then running BLASTX on your on your transcripts, and combining everything into an annotation report.
Sorry to interrupt you. We are not seeing your screen.
Oh, you're not seeing my screen again. All right.
Okay, yeah.
You can see it now?
No, not right now.
Let me restart that again. Is it working now?
Yes.
All right. Yeah, so this is I'm going to restart then. So yeah, I was saying this pipeline is composed of these different steps that start off with RNA-seq transcript assembly through Trinity, and then there's this whole annotation workflow. And so these different files are being shuttled through different tools, and each one of these tools is running off in its own containerized Docker image with its own resources. And this can accelerate the process immensely. In this case, just to give you an idea, I'm running Trinity on an AWS instance, which has 72 CPUs and 144 gigabytes of RAM. And as soon as it's done, the platform is kicking off this BLASTX step on the same kind of hardware to accelerate it as much as possible. Every step has resources that I've fine-tuned to try and get the most amount of speed for the least amount of cost. And it all happens. I can run 300 of these, and the platform manages all of the resource requirements, all of the provisioning of the compute for me automatically. And so if you're curious about, what the tool looks like, it's very simple. This is just, I ran Trinity in the most simple and basic way that is described, in their documentation. But again, you have a lot of flexibility. You can define any type of parameter to build, the workflow that you need. And so once you've built your pipeline, there's the GUI way of running it is, you click on it, you have start new analysis over here. You can decide to, I've exposed a number of different parameters for each of the steps and the tools. I can just go here and modify those if I need to. Obviously, for the files, since everything is on the platform, I can go around and then pick my fast queues for inputs and go around from there. But also, anything I run here, I can also just run through the command line interface or through an API. So when I need to scale up and run hundreds or thousands of analyses with the exact same pipeline from, I don't know, for example, a database of samples that I need to process, that can be done, with a single line command, because everything that has to do with managing the infrastructure, transferring the files back and forth to the compute node, all of that is being handled by the platform. So I'll show you an example of what it looks like to monitor a run. So I've launched this run here 57 minutes ago, just to show you what it looks like when it's running. So you can see here, I gave it, 4 fast queues. I didn't really change the parameters from what I've set as defaults. And then when I go into the details, I can have a look at, what the workflow is doing, what step it's at. So right now it's still at the first Trinity step. I can go to the logs. Their logs are the standard out and the standard out, standard error and standard output logs are captured automatically. So in this case, I believe, there you go. So it started. So this is being fed live. So you can keep track of what's going on with your runs live. So and obviously once the analysis is done, you can go back. So this one here I've ran successfully. I can go back and have a look at all the logs of the different steps, and they're all stored. Then you can query them back again. Everything is being tracked with unique identifiers. It makes life much easier in order to be able to go back and query exactly how a specific output was generated, which parameters were used, the different log outputs. It's all there, and you don't have to manage any of it. We also have, data warehousing capability. Again, you can have any number of
I don't know why we cannot see your screen. Can you reshare, please?
I'm going to redo that again.
Yes.
Is it working now?
Yeah, thank you.
Awesome. So, yeah, I went. No, now I was at the databasing capabilities. So, obviously, a lot of the data that can be generated, you might want to be able to easily build databases out of those. So in here, I've built a database from one of the outputs that, the reporting output, the annotation report output that was generated through the pipeline that I just shown. And so one of the features that is helpful, and now it's going to query a bunch of data, is that when I'm loading up a file that was produced by a pipeline, there's a lot of metadata information that is carried automatically with it. This can obviously be turned on or off. But in this case, I loaded a specific, so this is the final output of the pipeline that I've shown you. I also know which exact file identifier it came from in case I have many files that have the exact same name. It's also keeping track of which pipeline it came from, which analysis it came from. All of that metadata is tracked so that when you're querying your database, if you have a table that keeps being populated by the same kind of data, you can know exactly which entry came from what pipeline, what file, and obviously, you can figure out a lot more information once you have those identifiers. We do have automatic database ingestion that is set up, so you can set rules in order for, example, every time you run X pipeline, I want you to grab any file that has, a certain regular expression in their name, and then you can load those files up in the database automatically. And then obviously there you have the full feature set of being able to query files as you would query, your own local database. The advantage being this is all in the cloud, it's backed up for you, you have multiple levels of redundancy, and you can you can have multiple parties query at the same time. The level of flexibility and performance that you get is completely different. So the final aspect is what we call bench. So this is more of the workbench, the data science aspect of the platform. So by default, you can create workspaces that run on a default implementation. Sort of a default implementation of Jupyter Lab. So you can have Jupyter notebooks. And one of the interesting aspects is that we mount all of the data of your project in that environment. So in this case, I have a project folder here that was created 2022 years ago. That's not the case. It's just a little feature or a bug, depending on your perspective of the platform. But this essentially contains all of the data that exists within my project. So you could have possibly hundreds and hundreds of terabytes of data, easily accessible in an environment where you can manipulate that data very easily. In this case, this is a demo sort of notebook that showcases, being able to launch commands and then pull back, result data in order to analyze and compare VCFs for performance. But I'd much rather show you what the CLI would look like. So this doesn't have to run obviously in here. It can run locally, in my computer as well. So I can I can list all the projects. I can enter the project and then go around and say, hey, I want to list all of the data, and it's gonna, it prints it in this format, but basically it's showing me all of the data that, not all of it actually, maximum. I have a lot of data in this project, but it's gonna give you an entry per file, the paths, the file IDs, again, all of that to enable automation. But also what you can do down the line is also launch your pipelines from that. So I don't know my file IDs by heart, but I did prepare a one-liner to launch a pipeline. So if you see here, actually it went with I've launched a command where I'm starting a CWL workflow, and that's the pipeline that I showed you earlier. And then I'm defining, the name of the analysis that I want to put in. I'm defining what are my inputs through the file IDs, and then it's launching with default parameters. And then if I go back into my analyses, actually it's going to show up here. I just requested a new analysis 27 seconds ago. And so that will just run to completion on its own. I can run 100, 1,000 of those. You get the point. I've just run that one-liner, and every single step, all of the logistics of running the workflow are going to happen on their own. I can go and do something else in the meantime. One of the extra features that you can also have is you can customize what you have in these workspaces. So because we have a number of different types of hardware, there's even like types of GPU compute if you want to do AI training from data that you're generating downstream. But you can also build interactive web applications. So we do have this demo here of an R-Shiny web application. So this R-Shiny web application was designed for bulk RNA analyses. It's loading up. I'm going to give it some time. There we go. So essentially, this is in a context where, as I was saying earlier, bioinformaticians are often, there aren't enough of them, but they help everyone. And so what you can do is build, have a context where you're building a tool that will be used by someone else downstream that's a bit less, it's a bit more allergic to terminals and command lines and things like that. So you give them more of a visual cue tool where this here can load up data directly from ICA or locally, actually. And then I do have some demo data that I've loaded up here. So I can load up, RNA-seq count files. And then this takes care of running differential expression analysis with a very visual and interactive interface. And that could be very interesting for, again, in more of a collaborative aspect where you have a multidisciplinary team and you want to provide, again, the infrastructure is there. It allows you to build anything you want. And then you're kind of decoupling yourself from having to worry about storage, having to worry about compute. If you want to build a different version of this that has a different feature set for, a specific collaborator, you can just spin up a new instance. No need to think about any of the hardware. So this is really a tool that we've built to remove the burden of infrastructure, of storage, of compute, of sort of anything that doesn't have to do with bioinformatics. We're trying to remove that burden and give enough tools for bioinformaticians to just run what they want whenever they want it at the scale that they want. One of the advantages that customers find in this is they don't have to provision. They only have to pay as they go. You only have to pay, for as much compute, as much storage that you use. You don't have to provision, 1,000 terabytes of storage and, only use 100 of that the first year because that's how much data you've generated. So yeah, that was my brief overview of using ICA in a production environment, sometimes even not in a production environment. It's a lot of information, I know. I'm hoping I gave it a bit of justice in the amount of time that we have, and I'd be happy to take any of your questions right now.
Thank you, Sidki, for your relevant presentation. It was very interesting to see the platform that